Hello, my name is Christopher Bowman.
My name is Imakoji Aikoye.
And today we will be giving you a lesson in the world of algebra from the new 2015 SEEK Program Math Algebra booklet, as constructed by myself and my fellow SEEK program facilitators.
And the cover of the book will look exactly like this. Every material, every topic that is taught will come from this book. We hope you enjoy it. From the number of years of my experience teaching and tutoring math, it is very often that I hear students complain that math, and particularly algebra, it's very difficult and abstract. But what you don't know is what you may not have been taught, or that you may have been taught and not in the right way. I hope that this video is helpful in making you to understand that algebra is possible. So you already know what my name is. I want to spend a few minutes to tell you about my work and educational background. Educational-wise, I hold several degrees, 2 undergrad and 2 double master's degree from CUNY schools as well as from other private universities. For the SEEK program, I have tutored, I have worked as a supplemental instructor, I have worked as a supplemental instruction supervisor over the last more than really 9 years. I, at this point, continue to assist with the training of the SEEK program tutors. I help with workshop design and curriculum design in the area of math and science. I teach various math courses for the math department as well as for the School of Continuing Education and Professional Studies.
And also to give you a little insight about myself as to tell you who I am and what I do. I am a Lehman College graduate. I currently work for the SEEK department as a mathematics tutor, and I've also done supplemental instruction for the program as well. I've also worked for the math department at Lehman College as an exercise instructor, and this summer I will be doing an OSS class for the SEEK department as well. I am an honorary member of Chi Alpha Epsilon National Honor Society, and on the side I do personal training. Not to mention, not to boast too much, I am a pro basketball player.
Welcome to today's session. Today we're going to be considering an important topic in the field of algebra, polynomial expression. Under this important topic, we're going to be looking at addition, subtraction, multiplication, and the divisions of polynomial expression. I will try to simplify it and make it very interesting, and I hope you enjoy it. Thank you. My first polynomial example is that of an addition problem. 3x squared plus 4x minus 8 in upper parentheses plus 2x squared minus 2x plus 6 in upper parentheses. When you look at a problem like this, how do you visualize this problem? Is it a multiplication problem? Is it a subtraction problem? What makes it so? This particular problem is an addition problem because between the 2 parentheses, you have the addition sign. So for that reason, this is the addition of 2 polynomial expression. But the question is, how do you do this problem? My recommendation is this. Take the first problem, 3x squared plus 4x minus 8, and bring each of the terms in the second parenthesis unchanged because this sign is an addition sign. Write each one under its own kind. So I'm going to write the 2x squared beneath the 3x squared because they are like terms. Then negative 2x under the positive 4x because they are like terms. And the positive 6, which is a constant, under the 8, which is also a constant. Then I can draw a line beneath this. on the basis of the signs of each of the coefficient, I will then combine them. This is -8 and a +6. You keep the sign of the larger and subtract the smaller number from it. And so this would be -2. +4x and -2x. You keep the sign of the larger and subtract the smaller from it. This would give you a +2x. 3x squared and +2x squared. When you combine them, because they are both positive, this becomes 5x squared. When you are adding or subtracting, you don't mess with the exponents. This would be the way to solve this problem. So the problem that was the addition problem that I have just solved, I'm going to alter something here. When I do, the entire question becomes a different question. That is part of what makes algebra more of a visual course. So you have to really pay attention, watch, think, and do what you see. So I'm going to erase this positive sign or the plus sign. In place of that, I'm going to write a minus sign. So this problem, which was an addition problem, is no longer an addition problem because of the fact that between this parenthesis and this parenthesis, you have a minus sign. So this is the subtraction of polynomial problems. So the first thing you have to do, just like the addition problem, is to pull out the first expression out exactly as it is. 3x squared +4x minus 8. But by the distributive property, when you distribute this negative sign among each of this term, their various signs will reverse to the opposite. So therefore, +2x squared, because of this minus sign, becomes a -2x squared, and you write that under its own kind. This negative turns this negative sign into positive. So this becomes a +2x, and you place that beneath the 4x. This negative sign would also cause this +6 to become a -6. Once you have done that, just like with the addition problem, you would combine the terms according to their like terms. So this is -8 and this is -6. If the signs of two numbers or two terms are the same, you will keep that sign and add up the numbers. So this becomes a -14. This is a +4x and this is a +2x. You keep the same sign, you add them up, and that becomes 6x squared, 6x rather, and this is positive. Then you have 3x squared and -2x squared. You keep the sign of the larger, which is positive, subtract the smaller one from it, and so this becomes 1x squared. But writing the 1 as a coefficient is totally unnecessary in the field of algebra. This is how you will do a subtraction problem. Thank you. The third example is going to be a multiplication of two polynomial expressions. One, 2x plus 3 in the parenthesis, then another parenthesis, x plus 4. If you look at this question, there is absolutely not a sign of plus or minus between the two parentheses. Oftentimes, in the field of mathematics, parentheses are used to mean multiplication. So the absence of a plus sign or a minus sign between the two parentheses makes this a multiplication question. Some students or some instructors will call this the FOIL problem. The way I will do this problem is to take the first term in the first parenthesis, which is 2x. I will distribute that into the second parenthesis, which is x plus 4. But that's just one piece of the term in that parenthesis. The question is, what about the 3? I'll do the same. Positive 3 times the second parenthesis, which is x, plus 4. The beauty of doing this way is that it allows you to visualize the process of what you're doing, minimizing the chances of you mismatching or making error as compared with the FOIL method. So now you can distribute the 2x into this parenthesis. So 2x times x, you have 2x to the second power. 2x times a positive 4. You're going to have positive 8x. You go to the next part. Positive 3 times x gives you positive 3x. Positive 3 times a positive 4 would give you a positive 12. Then you can inspect what you have here. If there are any like terms, often the two middle terms are like terms. Combine them together. This would become 2x squared. Positive 8x and positive 3x would give you a positive 11x. And then you can bring down the constant, which is positive 12. When you look at the final stage where I am right now, these 3 terms are unlike terms. Therefore, you cannot combine them. Final answer. The last example on polynomial expression would be a division problem. 25x to the third power plus 15x to the second power minus 5x, the entire expression divided by a positive 5x. This is a fraction. All fractions are division. So how do I deal with this problem? My recommendation: take the first term, 25x to the third power, divide it alone by the 5x at the bottom. You take 15x squared, do the same, divide it by the 5x at the bottom. You take the negative 5x, divide it also by the 5x at the bottom. So 5 divided into 25, it's 5. X divided into x to the third, one of these x will cancel one of the x on the top, leaving you with x to the second power. Then 5 divided into positive 15 will be a positive 3. X will divide into x squared, leaving you with x. Then negative 5x divided by positive 5x, basically the same term dividing with its own kind, just that the signs are different. So anything that divides itself, it's always but a 1. In this case, since this is negative and this is positive, the answer is negative 1. So you have 5x squared plus 3x minus 1. Final answer. Now that you have learned how to add, subtract, multiply, and divide polynomial expression, I want to take you to a different but related topic of factorization. The question is, what is factorization? Factorization really comes from the word factor. So, when you talk about factorization, the meaning, I would best explain it this way. You've got the number 18. What does it mean to factor the number 18? To factor the number 18 simply means write 18 in terms of its own factors. One way to do that would be 18 times 1, 9 times 2, 3 times 6. 18 has been factored this way. 18 has been factored another way. 18 has been factored this way. But since we're dealing with algebra, I want you to borrow from this concept to try to understand exactly what it is that I'm going to be doing when I factorize polynomial expression. First example, 15x to the second power plus 3x. How do I factorize this? This is a binomial polynomial expression, meaning two terms. So to factorize this binomial expression, what it means is that I need to write this expression in terms of its multiplication form. So, to do that, I'm going to look at the coefficient 15 and 3. And I will ask the question, what is the greatest common factor for the two numbers? 3 is the greatest common factor, so I'm going to write it out here. Then I go to the letter x squared and x. The greatest common factor is the one with the least exponent, in this case x. I write it out here. Then I would write this parenthesis here, which makes this a multiplication statement. So 3x divided into 15x would leave me with 5x. 3x divided by positive 3x leaves me out with a positive 1. So that if you look at this new statement, it actually means 3x times this parenthesis, and in the parenthesis it is 5x plus 1. So if you distribute the 3x into this parenthesis, you're going back here. So you have this way rewritten this expression in terms of its own factor. I hope you understand that. Thank you. My next example is still the factorization of binomial expression, but this is the one that is done by the method of the difference of two squares. So if I have x squared minus 49 and I am told to factor that, so the question I really should be asking myself is, what is common? What is the greatest common factor? Obviously, nothing is common. But once I take a look at the first term, I realize that this is a perfect square term. This sign here, it's minus, and it has to be minus. And this is a perfect square term, 49. So what I need to do at the back of my mind is to take the square root of x squared, which is equal to x, the square root of 49, which is equal to 7. So to factor this expression, what I would need to do, therefore, is to take the x in one parenthesis plus the 7. And then I repeat the same thing, the x, but this time around, it's a minus 7. So this expression is now this answer here. And this answer is this parenthesis, x plus 7 times x minus 7. So x squared minus 49 has been rewritten in its own factor. So it has been factorized. So you have seen two examples of binomial expression. I want to go on to the factorization of trinomial expression. The first question would be 25x to the 5th power plus 15x to the 2nd power plus 30x. So, to factor this trinomial expression simply means to write this expression in terms of its own multiplication. To do that, you have to factor out the greatest common factor of all of this term. So if you look at the numbers, coefficient, 25, 15, and 30, the greatest common factor for all these three numbers is 5. You write it out. Look at the variables, x to the 5th, x to the 2nd, and x. You take the one with the least exponent, that would be the greatest common factor for the variable, which is x. Then you insert your parenthesis, 5x divided by 25x to the 5th power leaves you with 5x to the 4th power. 5x divided by 15x to the 2nd power leaves you with 3x. Then 5x divided into 30x would leave you with a positive 6. So this trinomial expression has been rewritten in a factored form, and this will be the final answer. So I want to do another example of trinomial factorization, but this particular one is the factorization of a quadratic expression. Quadratic, as you would see, x squared plus 5x plus 6. This is a trinomial expression, but it is quadratic because the highest exponent of any of this term is 2. That makes it a quadratic expression. The way to do this problem is to take the coefficient of the letter that is squared, or the term that is squared, and that is usually called the a, and you multiply it with the constant term, which is usually called the c. So you take 1 times a positive 6, you get a positive 6. Then you need to find two factors of this positive 6 that if you multiply them, you get the positive 6. But if you combine them, you get the coefficient of the middle term, which is usually called your b. So those two factors will be positive 2 and positive 3. So all you have to do to be able to factorize this is to break the middle term using these two factors. So this now becomes x squared plus this 2, but you add the x to it. And then positive 3, you add the x to it and bring down the 6. This is really the same thing as this, but you've been able to break it into 4 terms, which allows you to factor by grouping this 2 and then this 2. The greatest common factor of the first 2 is x, and so you are left with x plus 2. Greatest common factor here is positive 3. You're left with x plus 2. If you do it right, the 2 parentheses would come out exactly the same. So all you have to do for the final answer would be to take the outside terms, x plus 3 in one parenthesis, and one of the two identical parentheses, x plus 2, and this, in fact, is the final answer to the question. Thank you.
Another topic that we were dealing with today in mathematics will be inequalities. I will take you through a step-by-step process in solving for either a single variable or a variable dealing with an equation. The symbolism in which we be dealing with inequalities, we're dealing with less than equal to or greater than and equal to, and in which way it moves when you're dealing with multiplying or dividing by negative numbers, and how the symbols change dealing with self. We will also be going through a step-by-step process of how in the graph the inequality once we solve for the variable itself. And from that moment, it will tell us whether we're going to either be moving left or right, and whether the number will be a fixture in the number line that you're using or not a fixture in the number line that you're using. Hopefully this instructional video helps you to get to where you need to get to and learn everything you need to learn. Thank you. Hello, today we're dealing with inequalities as you see on the board written. The first thing I want to talk about is the symbolization. The first symbol I want to talk about is a less than sign, which looks as follows. Now this less than sign basically tells me that whatever I have, where the symbol is made right now, is whatever I have on my left side will be basically smaller than whatever I have on my right side. And basically, if we're dealing with an equation, more likely I will have my variable, probably another number, probably set less than to another number I have here. And at the end of everything, after I move everything when I need to, and I solve for that equation, whatever number is left over will be basically telling me that whatever I plug in for this variable will be less than the number that I have here. And this also has an opposite as well. Its opposite would be a greater than sign, which looks like this. Now, they both work the same way if I were dealing with an equation. Something on the opposite side, on this side, would be greater than something I would have on the right side. Now, these also have opposites as well. Not really opposites, but they have another part. The second part to this would be if I had a less than equal to sign or I had a greater than equal to sign. Now, the reason why I showed you that is because when I get to the next section or 2 sections from now, when I go to graphing, these make a big difference in how I'm supposed to graph and how it's supposed to look. Now, when I'm dealing with the less than and the greater than, the symbols are actually going to be parentheses, which is just like this. Now, these parentheses tell me that after I graph or after I solve for the variable from these two and after I put it on a graph, it tells me that one thing or another thing may not be included in the graph that I'm using. So on this one, it's going to tell me that whatever I have in here is basically going straight from here, from left to right. It's telling me it's going to go to basically infinity or positive infinity. On this side, it's telling me that from here, I'm going from whatever number I have to negative infinity, which basically tells me that this one's going for bigger and this one's going to smaller. Now, the second part of this would be if I'm dealing with the less than equal to or greater than equal to sign. Now, their symbols are actually different. They're actually brackets, which look like this. Now, these brackets do the opposite of what these two parentheses do. The brackets actually tell me that when I'm dealing with the equation, after I solve for the equation, after I want to graph it, it's telling me that the number that I find at the end is included in my graph. So basically, it'll still do the same way. This bracket will tell me, like if I had the number 3, it would say 3 would be greater than whatever, right? So basically, it would be telling me that I'm using number 3 going to infinity, whereas if I had here and there's a 3, I would just be starting at 3, but it wouldn't be included on that number line. Where here, I'm going to change the number around. I'm going to say I'm using -3. This would tell me that I want a number smaller than -3, so it's going to go to negative infinity, which will be going to the right. Now, in this case, it's telling me that I'm going to use the -3 in my graph, where if I had it here, it would tell me that -3 is not included in my graph. Hopefully this helped a lot of you figure out what's going on with inequalities, and we'll move on to the next section. Now we're dealing with the section with graphing. As you can see, I have two different equations. I have x is greater than 6, and then I also have x is greater than or equal to 5. So we know we're going to deal with a number line when we come to graphing, especially when we deal with inequalities. So the first thing I'm going to do is I'm going to create my number line. So my number line will look as follows, and I know that I have to split it in half. And the reason why I'm splitting it in half is to tell you that which side is what. So now on my left side of my number line is going to be negatives. And on my right side is going to be all positives. So according to my equation, it's telling me that x is greater than 6. So I know I'm going to be only dealing with the right side of the equation. So I need 6 notches. I'm going to make 6 notches. 1, 2, 3, 4, 5, 6. So my number 6 is here. So now it comes to the symbolization. I know I'm dealing with a greater than symbol, and it has no equal sign at the bottom. So it's going to be dealing with what? It's going to be a parentheses. It's going to be a parentheses facing to the right. Why is it facing to the right? Because the equation tells me that I'm using all the numbers greater than 6. But now here's the catch to this one. Since it's just a regular greater than sign, that means that as I make my line, I know that the number 6 is not included in that line going to infinity. So this is what my line will look like at the end when I finish for this equation. Now I move on to my second equation. As you can see, I have x is greater than or equal to 5. Now again, I start off by doing what? Making my number line. So at the second part again will be the what? Split it in half to designate what my sides are going to be. My left side being negative and my right side being positive. So now again, we read the equation one more time. It tells me that x is greater than or equal to 5, which tells me that I'm only going to be dealing with the right side again. So I need to make my 5 notches. 1, 2, 3, 4, 5. And now, there's going to be a different symbolization. Here, we have the parentheses, right? Now, on the opposite side, since I have a greater than or equal to sign, it's going to be a bracket instead. And again, that bracket will be facing going toward my right, because as the equation tells me, it tells me that all the numbers have to be greater than 5. But here's the catch to this one. 5 is going to be included in that number line. So when I put the bracket in which I need to put to start off my equation, actually start off my line, it's telling me that I'm going to include 5 in that line. So again, it's going to go straight out, and it should look something like this. So here's a regular greater than sign, here's a greater than equal sign. You can see the difference between the equations, and you can see the difference between the symbols. So I hope this helped everybody, and hopefully I said clear enough that you understand what's going on, and hopefully you'll check out more videos that we put up, and hope to see you then. A second ago, I told you about the symbolization, or how they were used if I was using with graphing or I was solving an equation. Right now, we're dealing with solving of 2 equations. I'm going to deal with the first one, and then we'll deal with the second one second. So now, here I have 2x minus 3 is greater than 9. So our first step would be to do what? Is to isolate the 2x by itself. So everything that's on the same side of the 2x has to be moved to the opposite side. So I want to get rid of this -3. So the first thing I need to do is do what? I need to change it to its opposite, which would be a +3. So now I know +3 has to go on the bottom of this 3. But as we know, whatever we do to one side, we have to do it to the other. And the reason why I'm saying that is because this sign is basically like a plane. It's telling me I have to do it to both sides. So I'm going to put a +3 under this 9. So our next step tells me what's going to happen, which is going to be I'm going to have to isolate this 2x, so I'm going to have to cancel out this -3 and this +3. The reason why I'm canceling them out is because they're opposites of each other. So normally, basically, they're basically going to cancel out. So as they cancel out, on this left-hand side, that 2x is going to drop by itself. So it drops by itself, and then as well as this symbol. So now I have to deal with everything that's going to be on the right-hand side, which is the positive 9 and the positive 3. Since my signs are the same, I keep my sign and I add my numbers. So since I'm dealing with the positive, I don't have to write the sign, I just add the numbers. So 9 plus 3 is equal to what? 12. So now I have a 12 on the right side and I have a 2x on the left side. Now, our last step is to get this variable x by itself. Now, a number and a variable is put together by multiplication. So for me to isolate it to get it by itself, I do the opposite, which would be division. So I'm going to divide both sides by whatever number is in front of the variable x. It could be a negative, it could be a positive, but whatever is there is what you divide by. So I divide both numbers by the number 2. So 2 divided by 2 gives me what? The 2's cancel out, and I get the variable x by itself. There was nothing going on at the bottom, so I'm going to keep the symbol that I have in the middle the same. And now on the right side, I have to do what? Divide 12 by 2, which gives me what? 6. So now we finished, we got our variable by itself, and we got our number, and what is set greater than 2. So now our second step what to be is to take care of the second equation. Now it's a little different. On this one I had the variable and I had the number second. Now in this case I have the number first and I have the number with the variable second. So it's still done the same exact way, there's no change. I want to isolate this variable and this number by itself because it's attached to each other. So what I have to do is I need to get rid of this 4. So since the 4 is positive, I have to do what? I have to make it a negative. And again, like I was talking about before about the planes, my plane is this less than sign. So that means that this negative 4 that I have on this left hand side, I have to also do it to the right hand side. So I'm going to put a negative 4 over here as well. So now, of course, you know what happens next is we have to deal with whatever we can on the left hand side first. This positive 4 and this negative 4, what happens is they're opposites, they cancel. So as they cancel, I'm done with this, so then that means that this negative 3x is going to drop. And as you heard, I said negative 3x because that sign was not attached to the 4, it was attached to the 3. The symbol doesn't change, it just comes down as normal. And now, as I said before, if I have numbers that have the same sign, I'm going to combine, which basically means add and keep the sign, because there it is, I like it. So I have 2 negatives, so my negative is going to stay the same. I have 11 plus 4, which will give me what? A 15. So now I'm left with a negative 3x on one side, less than negative 15. So now our last step again is to do what? Isolate the x like we did on the opposite side we showed before. So now in this case, in front of this variable x, I have a what? A negative 3. So I have to divide by a negative 3. And I'm going to do it to both sides. But there is a catch to this equation. I'm dividing by a negative number. So that makes something happen to this symbol in the middle. It's going to become the opposite of what it is. It also works as well like when it comes to multiplication. When you multiply or divide by a negative number, these numbers in the middle will flip. So, going back to the equation, I have a negative 3 divided by a negative 3. What happens? They cancel. And I'm left with the x by itself. Like I said earlier, since I'm dividing by the negative, the symbol in the middle now becomes a greater than sign. And then I'm going to divide negative 15 by negative 3. You already know, just like multiplication, if you multiply a negative by a negative, you get a positive. Same thing with division. You divide a negative by a negative, you get a positive. So now we're just working with 3 divided to 15, which is leaving with a what? A positive 5. So we now have solved for the variable for the second equation as well. I hope that the lesson that was taught today was very insightful.
If you have any other question, please feel free to visit the Lehman College SIG Tutorial Center located at the Old Gym Building, room 212.
There you will receive a variety of help from myself and our very qualified SIG tutors.
Thank you so very much for your time today. We hope to see you soon.